Hello everyone, and a warm welcome to you all. When we consider which companies have truly benefited the most from the rapid progress in artificial intelligence, it's clear that NVIDIA and its graphics processing units have become incredibly widely recognized even among the general public. Now, the GPU that Jensen Huang is holding, the technology for networking tens of thousands of these together is considered quite important, and as we build massive LLMs and increase according to scaling laws, the more we scale, the better the performance. However, with GPUs being in short supply, models like MOA have emerged. Models have also emerged, and everything has been centered around these scaling laws, leading to extensive discussions about the number of GPUs that can be secured. In our country, the lack of GPUs has limited research and development, which is part of that context. However, NVIDIA, the company that has been the biggest beneficiary of all this, has recently published a very interesting research paper. The paper contends that in the era of agent AI, small language models, or SLMs, will be considerably more efficient and perform better than large language models, or LLMs. The reasoning they present is so incredibly sound that by constructing AI data centers centered around the cloud, they have substantially boosted their revenue and the majority of. Given that NVIDIA's revenue comes from that, it's interesting they suggest that agent AI should shift to using small language models. Let's analyze why this discussion is emerging and examine the realistic claims made within the paper. If this scenario unfolds, how might the broader AI landscape transform, and which specific companies are truly poised to thrive? This is the particular paper we're currently examining. This is a paper titled Small Language Models, the Future of Agent AI that was actually released by NVIDIA. Here are some of the things they want to talk about in it. Commonly known as large language models, or LLMs, these models are often capable of surpassing human performance in a wide variety of different tasks. But if we consider the nature of agent AI systems, it's argued that SLMs are actually better than LLMs. Because fundamentally, agent AI systems are often required to perform tasks repeatedly, which are frequently highly specialized and need to be done over and over again. Given this situation, it's argued that SLMs can be sufficiently powerful and fundamentally more appropriate, plus they incur lower costs. So, in summary, that's the overall picture, and the detailed arguments are much more interesting. Let's take a closer look at them now. In fact, if you look here, they actually outline the general LLM to SLM agent conversion algorithm for us, demonstrating their very serious commitment to this endeavor. To begin with, to clarify why we should utilize SLMs, it's laid out in detail here in section 2.3. As previously stated, the majority of agent subtasks are highly repetitive. Their operational scope is distinctly specified, and they engage in very little conversational interaction. However, if you were to use large language models, limitations would become apparent immediately. This is because fundamentally, models such as ChatGPT and Gemini are all typically hosted on very large-scale cloud infrastructures. Actually, even Apple Intelligence, when it makes a call, it requests ChatGPT for improved performance. And likewise, when you use Gemini, you're also requesting it, even though they do possess individual on-device models. Nevertheless, if you're looking at using these large language models, the infrastructure needs to be heavily built out from the start. It requires a massive investment, which means it costs a lot. On the other hand, agent requests are very simple, making it somewhat inefficient to handle them with general-purpose large language models. So they've outlined all the benefits of these SLMs right here. Take a look. They are stating that SLMs are already adequately powerful. They are indeed powerful enough. And right after that, a series of examples are presented. Here, if you look at examples such as Microsoft Phi and then NVIDIA's Hugging Face model, you can see what aspects are sufficiently good about them. For example, in the case of Microsoft, the Phi 2 model, when looking at its general knowledge listening scores, performs comparably to a 30 billion parameter model, but it's significantly faster. It's 15 times faster, you see. It seems like implementing Agent AI could be quite a bit easier. With NVIDIA, this particular model is a 1 billion to 9 billion hybrid Mamba transformer model. I've actually covered Mamba in a prior video. It's considered part of the transformer next. However, concerning things like code generation, these are seen as comparable to a 30 billion LLM. This information keeps coming out. It's not possible for everything to be outstanding, as it uses fewer parameters. But if it's specialized for certain agent tasks, or even Salesforce content, that comes up later in the discussion. And also speaking of Salesforce, they are running an 8 billion parameter model, and its performance in terms of tool calling is quite similar. In what particular aspect? They're saying it's not lagging behind even when compared to frontier models like GPT-4 or Claude 3.0. So there's been a lot of very significant development in terms of function calling and performance efficiency, and what's more, SLMs are quite inexpensive for inference efficiency. They're truly small, aren't they? When compared to 70 to 175 billion LLMs, it's said to be roughly 10 to 30 times more affordable. There's also talk about edge deployment, modular system design, and so on. Therefore, combining multiple models to create an agent model is considerably better than building one enormous model to handle everything. They're talking about splitting tasks into smaller specialized models. That was interesting too. SLMs are described as being more flexible and adaptable, providing enhanced flexibility. This connects to the concept of democratization, where not only large tech corporations with significant financial resources can utilize them, but also individual users and smaller groups. By employing SLMs for the deployment of agent systems, a considerably larger number of applications can be generated, thus promoting broader democratization. Furthermore, when you drive things with SLMs, there are many efficient aspects and many areas where you can specialize, such as behavioral alignment and various other parts. These points were heavily emphasized. On the left is language models and on the right is code agency. Regarding language models, they essentially function as an interface for invoking a variety of different tools. This concept is commonly referred to as human-computer interaction, or HCI for short. So, ultimately, the LLM itself can directly invoke tools 1, 2, 3, and 4, and thus manage the whole workflow by itself. Additionally, there's a structure being considered where the large language model has both a large and a smaller language model, which enables it to call upon different tools for specific purposes. We can think of such a model, and in the case of a code agency, during the agent process, if any tool or large language model needs to be called, the controller requests the large language model and retrieves it from the tool, forming such a structure. Then, they briefly discuss an algorithm that enables the transition from an LLM to an SLM agent, which is quite interesting. The approach is fascinating. First, they collect user data. There are things like input prompts or the responses that come out as output, you see. They gather user information to log everything that was accessed by the tool, and then they eliminate any sensitive information from the gathered data. This constitutes the data curation and filtering procedure. Next, they cluster the tasks by collecting all of these prompts. And then, they'll figure out how the agent will operate. Using clustering techniques, they'll identify any repetitive patterns that emerge. So they take those repetitive parts, effectively group them as a single unit, and then proceed to select the appropriate statistical language model that corresponds to them. So basically, the concept presented for the overall outline is to take the actions that come from switching to large language models in many cases, filter them out, and then find the appropriate small language model that matches those specific actions. This process will continue to iterate and refine, improving over time. Now, if you look at the ongoing development centered on large language models, this is referring to very small AI models that can be operated on devices. This is actually the strategy that Apple is currently implementing. Of course, Google is also working on this, approaching it from the perspective of running what can be run on devices. As this technology continues to develop, what changes will occur? Ultimately, as I mentioned earlier, applications will emerge that embed various AI agents into multiple devices without the need for expensive large language model infrastructure. The most important thing is that this becomes cost efficient. Instead of processing all user requests right there within a hot and busy data center, that burden can actually be distributed to edge device users all across the world, like those with iPhones or Galaxies. This will very likely lead to the appearance of highly personalized or purpose-specific agents that offer even better, more enhanced user experiences. But why is NVIDIA researching this so extensively? Doesn't it seem a bit unusual? As I mentioned at the very beginning, NVIDIA has been selling a huge number of GPUs to build these massive LLMs, but they actually seem to have quite a bit of confidence in this. They're also preparing for SLMs, they say. Ultimately, the trend suggests that SLMs could become the future of agent AI, and this isn't solely NVIDIA's prediction. Such ideas have been around previously. However, NVIDIA isn't solely concentrating on large language models, you see. I think it's a signal that they might create entirely new GPUs that are specifically optimized for the inevitable growth of the SLM market. So, while things like HBM might be needed, looking ahead in the medium to long term, they'll be building new types of DRAM. You're seeing a lot of SoCs, and even things like LLW DRAMs emerging. Bringing in these kinds of things and doing this, the reason for that is it appears they are saying they are continuously interested in things that are more optimized for devices. And in line with that, they will provide a full lineup of devices that are perfectly suited for AI democratization, ensuring it can happen. Isn't that the kind of hint they are giving? That's what I think. NVIDIA has GPUs for gaming and separate GPUs for servers. And even within gaming GPUs, for example, the lineup varies from the 4060 to the 4090. NVIDIA aims to lead AI from client to server perspectives, thinking they'll drive everything with AI, so if infrastructure investment suddenly stops and big tech companies halt it, it will quickly be cut back, so they need to be well prepared. So instead of relying solely on the scaling laws of large language models, NVIDIA has also launched its own cloud services. And also, numerous robot platforms and similar technologies can ultimately be interconnected as agent AIs, which contributes to creating an image of leading technological innovation in these specific fields.